Hi, my name is Damien Bootsma and I'm a software consultant for Embarcadero Technologies. Today, I'll be walking you through DB Optimizer Developer. DB Optimizer Developer is our cross-database platform SQL performance tuning solution specifically for the developer community. The intention of DB Optimizer Developer is to be a part of your developer toolbox and work side by side with your IDE. The key features of DB Optimizer Developer are SQL profiling, SQL load testing, and SQL editing. And today I will walk you through each of these features. As I mentioned before, DB Optimizer Developer is a cross-database platform solution, and as such we support SQL Server, Oracle, Sybase, and DB2. For today's demonstration, I'll be using an Oracle 10G database. So let's start with our first feature, SQL profiling. Profiling is a process that is continually sampling a data source and building a statistical model of the load on the database. Profiling is used to locate and diagnose problematic SQL code and event-based bottlenecks. The application that I'll be using is a Delphi application, but you could be using C++ Builder, JBuilder, or any other development IDE for that matter. This particular application is a payroll app, and one of the functions is to calculate retrospective pay. Now the function works as intended, but it runs very slow. So today we'll use DB Optimizer Developer to investigate the database performance when this function runs. The first thing that I need to create is a new profiling session. From this profiling configuration dialog, we can give our profiling session a name, point to the data source we wish to profile, and an option of how we're going to save the profiling data. We can save it to disk, or we can save it to a repository. By saving it to a repository, we can centralize the profiling information and share this with others that may be able to provide guidance and details on assisting with our performance tuning exercise. With these values set, we can start profiling. Now the profile is running, let's execute our test case for calculating retrospective pay. You can see from this profiling session that a number of events have been generated on the database. In our scenario, I can see that the majority of these events is user I/O, and I can get this information from the legend defined above. In the middle of our profiling view are in-depth database metrics that focus on SQL statements, which are the SQL statements that have been executed by the database during our profiling session. Events, the database events that were triggered based on the SQL statements that were executed, and sessions. These are the sessions that were opened during the profiling. This detailed data provides us with a starting point for investigating our performance problem. I can see from the SQL Statements tab that our query is causing an extremely large amount of database activity. And from the Events view, I can also see that the majority of the database activity is user I/O related. And I can also see that by selecting this query, I can drill down into more detailed data about my query. I can see the SQL details, and this contains information like the mode that the database optimizer used for my query. Perhaps there's an Oracle hint that I can use to direct the database optimizer to use another mode to improve performance. I can also see the events view and the events that were generated on the database based on my query. Again, I can see that the user I/O events are the majority of the events generated for my query. But I also now have additional information about the particular user I/O event, DB file sequential read. If I right-click on the event, I have the additional ability of being able to view online documentation about this wait event to get more information about what it is and what causes it. And this is going to help make an informative decision on how to tune the query or also how to configure the database. We saw how our query performed as an individual execution, but this type of execution is not necessarily the case in the real world. Multiple users would be using our application, and many users would be interested in calculating their retrospective pay. The job of our next feature, the SQL load testing capability, is used to simulate these types of real-world scenarios, and combining this with SQL profiling gives you the added benefit of seeing how the database copes with this load. The load testing feature is also a powerful way to test whether or not changes to your SQL code are in fact producing performance benefits. So what we'll do now is take our problematic query and let's run this under load and see how the database copes when we simulate multiple users executing that query. In order to do this, I need to create a load test and then start the profiler once more. So here is my load test details, and here is the problematic query that we've been running. I'm defining a number of parallel sessions. In this case, we'll have 5 concurrently executing, and I'll execute those 5 times. To make this load test a little more realistic, we'll generate random intervals of sleep time between executions, so we can really understand how it might work in the real world and how the database copes with that. So before running this, we'll start the profiler. Now that our profile is started, let's start the load test. The CPU line is a yardstick for performance on the database. When active sessions is larger than the max CPU line, there is a bottleneck on the database. By using the load test feature and the profiler in conjunction with one another helps us better understand how an individual query works under load now and how the database deals with that load. And this will give us further information about our problematic query and what we might do to be able to solve that query. The final feature that I will show you is the SQL editing capabilities of DB Optimizer Developer. The SQL editing capabilities provide the developer with the ability to rapidly create SQL code, but also ensure that the SQL code is of the highest quality. The way this happens is through code templates, code assist, code formatting, and code quality and quick fixes. DB Optimizer Developer provides code templates for DML and DDL statements. Now I've created a code template for a simple select statement. So by typing the simple keyword and control space, I can see my code template, and to the right I can see the details of that particular code template. So I will select that code template, and it then enters in my placeholders with my standard syntax for this SQL select. I'm now going to change the placeholders and include some more detail, and also point out the second feature of SQL editing, which is code assist. If I type HR followed by the dot command, code assist is enabled, and I can see the available tables that I can use and access information from. Code assist provides the developer with the ability to look inside the current object and view details such as tables, views, and columns. This feature ensures that the developer uses the available child objects and helps to avoid any syntax errors by typing in an incorrect or non-existent child object. So I'm just going to finish this query off so we can move on to the next feature of the SQL editor, which is code formatting. Code formatting provides us with a way of defining rules that our SQL code should adhere to. If there are rules that you make use of when writing SQL code, then you can apply them to DB Optimizer Developer. This ensures that DB Optimizer Developer produces SQL code that is in accordance with any SQL development standards that you have in place. So by simply right-clicking in my piece of SQL code, I can go down to the option of Format SQL, and that will then take the rules that I've defined in DB Optimizer and apply them. The fourth feature of SQL editing is code quality. Code quality parses your SQL code directly in DB Optimizer Developer and looks for any common flaws such as Cartesian joins, missing valid join criteria, and columns that are mismatched in a query. In some cases, not only will DB Optimizer Developer alert you to the problem by placing a warning in the gutter, as you can see here, but it can also provide a quick fix for you. This feature provides the developer with a fast way of making sure that their SQL code is not only syntactically correct, but also helps avoid any common problems prior to execution. Now in my query here, r.region_name is underscored with this yellow line. By placing my mouse over this, I can see there is a quick fix available for the problem of usage of an inner join instead of an outer join. So by choosing the option available, my query is now fixed, and I now have the ability of executing this query within DB Optimizer Developer. So, to summarise what you've seen today, DB Optimizer Developer is a cross-database platform performance tuning solution. SQL profiling captures in-depth, valuable database performance details that you wouldn't otherwise get from your IDE. The data provided by the profiler will help you make informative decisions on the performance of a query, the configuration of the database, or even the hardware that the database server is deployed on. SQL editing provides the developer with the ability to rapidly create SQL code, but also ensure that the SQL code is of the highest quality. And load testing capabilities provide the developer with a mechanism to create realistic SQL loads, and combined with the profiler, enables the developer to see how the database handles that load. I encourage you to visit our website at www.embarcadero.com and download an evaluation today. Thanks for your time.